Hello, friends. Welcome to our sleepy science journey. Tonight, we explore the quiet city of light we call the Milky Way, built of suns, shaped by gravity, and glowing with patience. We'll move through its neighborhoods, its hidden heart, and the dark lanes where new stars are born. Let your breathing slow with the rhythm of its orbit. And if this calm passage through the galaxy soothes your thoughts, please like, share, and subscribe. Help us pass this quiet wonder forward. A pale ribbon of light stretches across the night, soft and unbroken. Yet what we see as a simple arc is only perspective, the quiet illusion of depth flattened by our view. We are looking along the plane of the Milky Way, not down upon it. Stars overlap like distant lanterns seen through fog. Dust lanes carve dark seams across that pale brightness. Layers of space stack upon one another, thin, thick, near, far, all folded into a single silver band. The galaxy's shape hides in this angle. What looks smooth is a structure of two disks, a thinner, younger one, where star formation still breathes, and a thicker, older one hovering above and below, filled with stars born when the galaxy was rougher, collisions frequent, and order still forming. In the thin disk, stars travel in nearly circular orbits, gliding along predictable paths like cars on a calm highway. In the thick disk, orbits tilt and wobble, a quiet echo of that earlier, more turbulent time. Light alone cannot tell the full story. To see the skeleton beneath the glow, astronomers listen to wavelengths beyond sight. At 21 centimeters, radio waves from neutral hydrogen trace spiral arms far past where visible starlight fades. Cold molecular gas maps out the ridges where new stars are gathering. Dust, though it obscures, also helps it cools gas so gravity can take hold, turning clouds into nurseries. The galaxy shines across many registers. Infrared warmth from red giants and grains, radio hum from gas rivers, ultraviolet spark from newborn clusters. Each wavelength adds a layer, a different timbre to the same deep chord, and through that complexity runs something intimate familiarity. The Milky Way we see is not a distant object. It's the neighborhood seen edge on, the soft reflection of home stretched into infinity. We are part of what we're observing. Our star, our planets, our breath, all belong to one lane in this luminous current. From inside, we cannot command the view. We can only learn to read it gently. Step by step, astronomers built a sense of distance. Parallax, the shift of a star's position, as Earth moves, extends a ladder outward, one rung at a time. Standard candles, stars whose brightness is known, push that reach deeper. Proper motions trace their slow drift across the sky, showing how the crowd moves as a whole. Layer those measures, and the smear becomes a map, a city seen not as haze but as structure. Imagine standing in a forest and staring down a corridor of trees. At first, the trunks blur into a solid wall of brown. Only when you learn to separate near from far does the depth return, branches receding, openings appearing. The Milky Way's light behaves the same way. What feels like density is perspective. Each dot holds its own distance, its own story of motion and age. Through new eyes, infrared, radio, X-ray, the galaxy opens. The thin disk stretches roughly 100,000 light-years across, and only a few thousand thick. Stars in the plane revolve around the center every few 100 million years. Dust lanes trace the inner spiral arms where stars are being born. Between them lie clearer corridors, wide and calm. The thick disk extends farther above and below, home to older, redder stars with different chemical fingerprints, more oxygen, less iron, the signatures of earlier times. These layers move together, yet distinct, like two currents in a single river. The younger disk follows a smoother path, shaped by ordered rotation and steady star birth. The thicker component remembers upheaval, gravitational jostling from early mergers, turbulence that puffed it outward. Even now, faint ripples move through the stellar population, remnants of passing satellites and long-ago encounters. Each ripple, a whisper of history still unfolding. Dust, too, holds dual roles: concealment and creation. It hides the heart of the galaxy from the naked eye, but it also guards new stars from harsh light while they form. Behind those dark lanes, clusters assemble in secret. When they ignite, ultraviolet light seeps through the gaps, tinting nearby clouds blue. Every twinkle you see along the Milky Way's spine may be a cluster just breaking free from its cocoon, or a dying star shedding its final glow into the night. Seen in motion, the Milky Way breathes. Gas flows inward along spiral arms, condenses into stars, then drifts outward again through winds and supernovae. Over billions of years, that cycle keeps the disk alive. Gravity maintains the shape, but feedback from light and death sculpts the details. A galaxy may seem eternal, yet it's always rewriting itself, layer upon layer. From our quiet place within, we see only one side of the story. Looking outward, we measure the rotation curve, how stars at different radii move around the center. The surprising constancy of that curve revealed dark matter, an unseen mass that holds the disk together. Without it, the Milky Way's edges would drift away into the dark. With it, the galaxy remains balanced, a vast wheel turning without haste. The feeling that lingers is one of belonging. When we gaze at that milky band, we're not outsiders peering at a distant wonder. We're participants in its slow spin. The light that reaches us began its journey before human memory. Yet it comes home tonight, finding our retinas, our thoughts, our words. The stars are neighbors, some a few light years away, some tens of thousands, yet all share the same orbiting dance around a shared heart. As instruments improved, our sense of place sharpened. What once was an unbroken glow is now a map with detail, finer than imagination, arms branching, gaps linking, motions unfolding. The thin disk, the thick disk, the halo beyond all part of one organism, patient and self-renewing. The forest is no longer a wall. It's a landscape we can name, leaf by leaf. The constant face of the Milky Way is thus both illusion and truth. From afar, it would appear as a barred spiral, elegant and defined. From within, its texture, light and shadow, a quiet corridor stretching through our nights. Both views are real, both incomplete. Like any home, it's clearest when you move through it slowly, noticing layers instead of outlines. And as we rest beneath its arc, we share its motion, a small point in a wider drift, carried through time by the same gravity that binds the stars. The pale band crossing the sky is no stranger's river. It's the mirror of our own endurance. And somewhere, beyond the dust and distance, another civilization may look inward from their lane in the same great disk, seeing their own ribbon of light, and wondering, softly, if someone else calls it home too. Another lantern appears, not a new light, but the same one seen with new clarity. The Milky Way, calm and immense, continues its steady turn, and we, inside it, continue to listen. The sun does not sit still. Even as we sleep beneath its faint reflected light, it moves slowly, endlessly around the great center of our galaxy. At first thought, it seems impossible. Something so steady, so faithful in its daily rise and fall, is in motion through a sea of stars. Yet, it is true. The sun and every planet around it are part of a vast orbit, circling the Milky Way's heart at nearly 200 kilometers each second. That's fast enough to cross the distance between cities in the blink of an eye. Yet the circle it draws is so immense that one full revolution takes about 250 million years. A galactic year. One loop of time long enough for continents to drift, oceans to open and close, and entire lineages of life to appear, change, and fade before the cycle completes again. In the scale of such motion, speed becomes stillness. The sun races through the dark, yet the pattern is so slow that to our eyes it feels eternal. Our days rise and fall, our years pass, but the galactic background changes at a pace almost beyond imagination. Stars we see tonight are neighbors only for a brief cosmic moment. Given enough time, the sky itself will rearrange. Each star follows its own long path, yet all are bound together by the quiet gravity of the same invisible center. The orbit is not a perfect ring. The sun moves in a gentle weave, rising and sinking above the galactic plane like a leaf drifting on a vast invisible tide. Every 30 million years or so, it crosses the mid-plane again, pulled by the gravity of the disk's denser regions. That slow vertical oscillation is written into the structure of the galaxy itself. Mass concentrated near the middle, a soft restoring pull guiding everything back toward balance. At the same time, the sun drifts slightly inward and outward over millions of years, sliding through resonances with spiral arms and the bar-shaped core. A star born closer to the center may wander outward, another may drift in. The galaxy breathes in these motions, trading its stars between neighborhoods without hurry, like a tide reshaping sand, yet keeping the shore. Our solar system's current address lies in a quiet suburb known as the Orion Spur, a smaller bridge of stars between two larger spiral arms. Here, space is open. Collisions are almost non-existent, even when stars pass near one another. Near means light years apart, vast enough that their planets remain untouched. The distances are kind, protective. It is this cosmic breathing room that allowed Earth to become stable, oceans to learn the rhythm of tides, and life to find the time it needed to evolve. Still, the neighborhood isn't fixed. Over tens of millions of years, the sun drifts through regions where the density of interstellar gas rises and falls. In one epoch, the solar system might sail through a bright patch of a spiral arm, full of newborn stars and glowing nebulae. In another, it might cross a calm, darker corridor between arms where space is thinner, quieter, and the night looks emptier. These shifts may gently alter the climate of a planet or the texture of its sky, but they happen so slowly that no living creature feels the change. It's strange to think that Earth's own history, the age of reptiles, the rise of forests, the spread of humans, fits into only a small fraction of one galactic orbit. When the first dinosaurs walked through fern-lined valleys, the sun was on the far side of its path around the galaxy. Now, hundreds of millions of years later, we occupy a completely different stretch of that circle. Yet, the stars still shine, and the galaxy continues to turn, patient as ever. Astronomers call the journey a galactic year, but it is less a clock than a gentle heartbeat. The sun has completed only about 20 such revolutions since it formed. In that time, mountains have lifted and worn down, oceans have appeared and retreated, and entire species have emerged and vanished all. Within a handful of galactic minutes, our orbit tells us how brief our sense of history really is. Even civilizations that span thousands of years are flickers compared to the rhythm of the stars. And yet, this slow, steady motion offers comfort. The sun will not break its path tomorrow, nor in any lifetime we can name. Its orbit is a promise of continuity. The gravitational pull that shapes it is unyielding. the balance exact. The Sun and its family of planets trace a path around the Milky Way's center, kept in line by a delicate tension between inertia and attraction. Space may seem empty, but it hums with this invisible structure, a quiet thread linking every orbit to every other. The Earth, the Moon, the comets, in their long stretched tracks, all move together, caught in the same grand turn. And because everything shares the same motion, we don't feel it. There's no wind of speed, no sense of drift, only the quiet assurance that night after night, the constellations keep their places, even though each star is slowly sliding through the dark. Over eons, the shapes of those constellations will blur, the familiar patterns dissolve into new ones, but the movement itself never stops. Our place in that movement is serene. The solar system's velocity is enormous, yet it has carried us through a remarkably peaceful region of space. No nearby supernova threatens us. No passing giant star disturbs our orbit. We drift in balance, close enough to the galaxy's heart to feel its pull, far enough to avoid its turmoil. The calmness of our cosmic street may be one reason life on Earth had the chance to grow complex. Safety, in this sense, is not luck, it's position. Imagine, for a moment, drawing a loop of string around a lantern, then slowly sliding that loop outward by the width of a fingertip with each turn. That's how the Sun's path shifts across ages. A smooth drift, too slow to notice, too sure to fear. Each subtle change brings us into new neighborhoods, places with different clouds, different patterns of interstellar dust, different constellations forming at their own pace. The galaxy is vast enough that we will never trace the same exact path twice, and yet the journey always circles home. Every orbit tells the same quiet truth. Motion and stillness can coexist. The Sun hurries, but it feels like calm. The galaxy spins, but it feels like eternity. In that slow harmony lies a mirror for our own lives. We move through days and years thinking we are still, and only when we step back, only when we think in millions of years do we see the great curve we're part of. As the Milky Way continues its own rotation within the larger local group, dragging its spiral arms through the dark between galaxies, the Sun remains one of billions of lights keeping pace. It doesn't race ahead, it doesn't lag behind, it follows its course faithfully. The same way Earth spins and orbits, the same way our thoughts circle the comfort of what feels known. The galaxy does not rush us. It invites us to rest inside its patience. And so, as you close your eyes tonight, you are already moving silently, swiftly, through a sea of stars that will never feel the wind. The Sun carries us along its orbit with effortless grace, a cosmic vessel tracing an endless curve around a heart we cannot see. Each breath you take belongs to that voyage. Each dream, another small revolution within the grander one. Nothing is standing still, and nothing needs to. The galaxy turns, we turn with it, and in that vast motion, there is peace. At the quiet heart of the Milky Way, light thickens. Star counts swell into a glowing bulge, a crowded congregation of suns packed close enough for their combined haze to seem like a living pulse. Within that bulge runs a bar, long and faintly curved, a slow beam of starlight threaded through the galactic core. It is not solid, not rigid like a bridge, but a pattern, a rotation of countless stars and gas clouds moving together, their gravity weaving an elongated rhythm across tens of thousands of light years. The bar turns once every 100 million years or so, patient and unhurried. As it moves, it draws matter inward, like a hand gently guiding sand along a shallow groove. Where the bar's ends meet the inner disk, gas collects in smooth streams. It piles up and swings outward, curving into the spiral arms that wind around the galaxy. These arms look like sculpted ribbons of starlight, yet they are not fixed structures. They are density waves, moving patterns, where gas and dust are momentarily crowded together, then released again. Like cars slowing and bunching in city traffic, interstellar gas compresses as the wave passes through, only to drift free once more. That compression is enough to light the match of creation. Cold hydrogen clouds collapse, their centers warming until nuclear fire begins. New stars blaze out of the gathering darkness, many of them hot and blue, living fast and fading quickly. Those bright clusters outlining the arms are the galaxy's fresh handwriting, tracing where the wave has just passed. But they will not stay there for long. Stars drift out of the spiral as they age, moving on through the disk's soft rotation, their light fading into the broader haze. The arms continue, but not because the same stars remain, rather because the pattern persists, carried by the steady gravity of billions of suns. The disk itself is layered like a page written in two inks. The thin disk, only a few hundred light-years thick, holds most of the galaxy's current star birth. It is cool, rich in molecular gas, its clouds sprawling for dozens of parsecs. Within it lie the open clusters, small families of young stars still near their birthplace. Here, the spiral arms are most vivid, glowing with emission from hot hydrogen regions, the breath of newborn stars. Above and below this lies the thick disk, a more ancient layer, nearly 1,000 light-years tall. Its stars are older, poorer in heavy elements, and their motions more erratic. They tilt and sway through the plane, shaped long ago by minor mergers and internal heating, carrying the memory of the galaxy's youth. Both disks feel the pull of the bar, though differently. The gas of the thin disk is supple. It flows along the bar's lanes, feeding the inner regions and forming luminous rings around the core. It responds quickly, its movements guided by gravity like water following a carved path. The stars of the thick disk are less easily moved. Their orbits shift slowly, subtly, over millions of years. The bar's influence stretches them, adjusts their angles, and rearranges the distribution of angular momentum, never sharply, always through patience. In this quiet choreography, structure acts as guidance rather than command. The bar and the spiral arms do not force. They suggest. A wave of density passes, and gas compresses just enough to awaken new light. Then the pattern moves on, leaving the stars to drift into wider orbits. Over billions of years, these gentle nudges accumulate. The bar can grow stronger or weaker. It may buckle slightly, thickening the inner disk and shaping the central bulge into a form faintly like a peanut, its sides swollen by the slow bending of orbits. Even the pitch of the spiral arms, the tightness of their curve can change, responding to shifts in the galaxy's mass and rotation. Nothing is fixed. Everything evolves by quiet persuasion. The Milky Way, in this sense, is a self-balancing system. The Espaciosa bar redistributes momentum from the inner disk outward, helping the whole galaxy settle into a new equilibrium. Gas flows inward, stars migrate outward. Over immense timescales, this trade maintains the spiral's grace. If one could watch the Milky Way over eons, its form would seem to breathe, expanding, contracting, folding gently into new symmetries. Imagine standing at the edge of a vast lake as a slow breeze crosses it. Ripples spread outward, rising and falling in measured rhythm. The water itself barely travels, yet the pattern moves, alive with motion that belongs to the wave, not the fluid. Sail through such ripples, and you feel a lift beneath you. Pause, and they drift away, leaving calm once more. The Milky Way's waves behave the same. Stars and gas shift in and out of pattern, but the design endures. gliding across the disk like an invisible tide. These ripples are gravity's handwriting. Astronomers read them by mapping the locations of stars, tracing how gas flows along the spiral lanes, how its velocity changes near the bar. Infrared surveys reveal the bulge, thick and bright, hiding behind the dust of the inner disk. Radio telescopes follow the movement of hydrogen clouds, measuring how they twist and gather near the bar's tips. In these measurements, the galaxy's syntax appears bars as commas, spirals as phrases, the whole disk composing a slow sentence about balance and time. Even the smallest details echo the same rhythm. In the thin disk, stars move around the center once every 200 million years, faster near the core, slower at the edge. The bar itself rotates more quickly, overtaking the spiral arms and driving waves that sculpt the inner regions. At resonances where these patterns meet, energy exchanges hands, gas rings form, orbits shift, and the galaxy subtly reshapes itself. These processes are not sudden. They unfold over hundreds of millions of years, smooth as tides on a planetary scale. Through it all, the Milky Way remains serene. Its heart glows steadily, fed by the gas channeled inward along the bar. The outer arms keep their soft open curves, bright with scattered clusters and star-forming knots. From far above, it would look like a whirl of pale light around a golden core, a spiral that seems frozen yet is always in motion. And somewhere within that pattern, our own sun drifts one small participant, orbiting quietly among hundreds of billions. The galaxy's order is not mechanical but organic. It grows by suggestion, by response, by resonance. A passing wave creates beauty for a time, then fades, leaving the potential for another to follow. What begins as structure ends as motion, and motion itself becomes structure again. This is the way of the Milky Way's heart, not a command, but a conversation carried across space and time. As the tide shifts in the cosmic sea, another wave prepares to rise. The bar turns onward, the arms adjust their curves, and the stars, ancient, newborn, and yet to come, continue to listen to gravity's quiet instructions. Each orbit, each ripple, keeps the great pattern alive, turning motion into music and music into calm. At the very center of our galaxy, where the sky thickens into a crowded glow, gravity gathers itself into a single, quiet command. Astronomers call the source Sagittarius A*, a supermassive black hole a few million times the sun's mass. We don't see a dark disk edged in fire. We see motions that refuse any other explanation. Nearby, stars whip around on tight ellipses, changing speed as they fall inward and ease away again. One of them completes its loop in only a couple of decades. In a universe where most orbits take ages, that brief turn is a signature. Only something heavy and compact can tug light-breathed stars into such sharp curves, then let them fly. The central region swarms with matter, stars packed together, far more densely than in our neighborhood. Gas clouds drift, collide, and shear. Dust sits in lanes that block visible light as surely as curtains. Optical telescopes see a thicket with no path. Infrared instruments slip past the dust and watch those orbits unfold. Radio arrays find compact knots, flares, and filaments, and fix the black hole's location with patient triangulation. When a passing cloud strays too close, tidal forces stretch it like taffy. Part of the gas heats as it spirals inward, glowing in X-rays for hours or days before the signal fades. Most days are quiet. Some days are not. Today, the core rests at a low simmer. Its feeding rate is small compared to active galaxies that blaze as quasars. Even so, echoes hint that our center has flared before. High above and below the galactic plane, enormous lobes of high-energy light suggest earlier outbursts from the heart. They hang there like the afterglow of a breath taken long ago. In the near surroundings, a ring of dense gas encircles the black hole on scales of a few light years. It's not a solid ring, more a looping track where parcels of gas crowd together, where pressure peaks, stars begin. Young clusters sprout inside the central molecular zone, proof that even on hard gravity, creation finds room. Crowding does not mean chaos. Collisions between stars remain rare, even here. Distances are small by galactic standards, yet still vast compared to stellar sizes. What shapes the region is not impact, but close passage. Encounters trade energy between orbits. Some stars drift deeper toward the core over many shufflings. Others climb outward, a little at a time. Whole clusters can move inward, feel the black hole's gradient, and lose their outer members to tides. Those stripped stars become streams that wrap the center like delicate threads, each one tracing the path the parent cluster once held. The bulge around the core swells three-dimensionally and looks pinched at the waist when seen from the side. That geometry likely arose as the central bar in the disk buckled over time, lifting stars into a boxy, peanut-like shape. Within that bulge, orbits are not simple circles. Families of paths weave around the bar's influence and the black hole's pull, yet they fill space in repeatable patterns. Over many cycles, the whole region behaves like a well-tuned machine. The center sets the potential. Everything else plays along. Gas responds most strongly to guidance. The bar funnels material inward along two great lanes. Near the core, those lanes curve into a series of inner rings, where shocks slow the gas and pile it up. There, star formation lights in clusters, some no older than a few million years. Massive young stars flood the area with ultraviolet radiation and winds. Those winds carve cavities and push on nearby clouds. The feedback sounds violent when listed. In practice, it regulates the pace. Too much gas in one place, and newborn stars push some back. Too little, and quieter infall fills the deficit. The result is a long, low murmur of growth rather than a blaze. Sagittarius A times itself is small compared to its influence. A black hole a few million solar masses across would fit well inside the orbit of Mercury if you could. Place it in our system, yet its gravity sculpts a region dozens of light years wide. Close in, time runs differently by small degrees, and orbits precess under the combined pull of mass and curvature. Those subtleties become measurements. Astronomers track a star's path through periapsis and back, compare it to Newton's clean ellipse, and read out the extra turn as proof of relativity written on the sky. The center gives us a laboratory that needs no construction, only patience. Flares from the accretion flow arrive unpredictably. Most are modest, short-lived, spikes in infrared or X-ray light. They trace small knots of gas heating as they fall inward and shear apart. A few are brighter, brief enough to imagine a single clump making a final arc before surrendering to the horizon. These events don't announce danger, they announce proximity. The black hole's appetite is light by quasar standards, but it never goes fully dark. The quiet does not mean absence. It means balance between supply and release. The emotional lesson of the core is steadiness. The center does not need noise to hold authority. It sets the potential well. The shape of the bowl and stars roll accordingly. On human nights, the idea feels familiar. A heart does not speak, it sets a rhythm. Cities keep order not only by walls, but by the layout of streets. The galactic center is such a layout. Paths that seem tangled at first resolve into families once you watch long enough. What looked like crowding becomes choreography. Infrared surveys reveal a nuclear star cluster, hundreds of thousands of stars, in a volume a few light years across. Some are old red giants with swollen atmospheres. Some are hot, luminous young stars that shine blue-white in deep images. Their presence so close to the black hole raises questions. Did they form in place from dense gas that somehow resisted being torn apart? Or did they form in clusters farther out and ride inward over time, surviving tidal pruning to settle near the core? Both channels likely operate. Evidence points to repeated episodes of infall, feeding new rings and building young populations on top of older ones. Around and beyond the nuclear cluster, gas traces miniature spirals that carry material toward the inner ring. Dust grains glow faintly in the mid-infrared, marking lanes you cannot see with the eye. Radiomassers pinpoint regions of dense, warm gas and let astronomers measure motions with astonishing precision. Piece by piece, a map emerges in which everything has a reason for being where it is. The black hole is not the only actor, but it is the stage's dip, the reason every scene bends toward the center. Tidal disruptions, when a star wanders fatally close, are rare in any one galaxy, yet over long times, the center will collect a small library of them. Even near misses leave marks. A giant star can lose some of its outer layers to the gradient and continue on, lighter than before. The debris from such grazes becomes fodder for bright flares and short-lived streams. Nothing in the core wastes anything for long. Gravity recycles. Even the quiet tells a story. The low feeding rate today suggests that most of the gas arriving at the core stalls in orbits rather than plunging straight down. Magnetic fields and turbulence likely help heat the flow and vent much of it back out before it crosses the horizon. That inefficiency keeps Sagittarius A times faint most nights. It also spares the surrounding region from constant glare. Stars can form, clusters can survive, and we can look inward without being blinded. If you need a picture, make it gentle. Imagine a whirlpool, seen from a safe distance, not a violent drain but a fixed center that teaches the surface how to turn. That is the galactic heart. It organizes without shouting, it holds without grip. It allows a complex neighborhood to remain busy and, somehow, calm. As the tide shifts within, gas will feed new rings, clusters will age, and the black hole will flare and sleep by turns. The city endures because the plan beneath it is steady, and the plan is gravity. Another lantern appears, not in brightness, but in structure. The bar's long arms guiding fuel inward, the bulge pinched by past bending, the nuclear ring blooming stars that will later wander the broader disk. From the center outward, the same theme continues, motion guided, not forced, energy balanced, not spent at once. And still, the night continues, carrying us from this quiet heart toward the wider currents that thread the Milky Way's vast and gentle spine. Under the silent arc of the Milky Way, the stars circle as if remembering an ancient rhythm. Their motion should slow as the distance grows, like dancers easing at the edge of the hall. Yet it does not. The outer stars move swiftly, keeping pace with those near the center, their paths holding firm against the pull of emptiness. Astronomers trace these motions, plot their speeds, and find a curve that stays high instead of falling. It is a quiet rebellion against expectation, a sign that there is more mass than the light can tell. The luminous disk alone cannot account for such loyalty in motion. Something unseen steadies the galaxy, enfolding it in an invisible hold. They call it the dark matter halo, a vast, spherical shroud of gravity that does not shine or absorb, but insists on being known through the behavior of others. It is as though the stars are leaves caught in a slow, unseen current. The halo's presence bends paths, sculpts orbits, and defines the edge of what belongs to the Milky Way. It extends far beyond the glowing arms, out where the faintest traces of gas thin into intergalactic space. If you could drift there, the light from the disk would fade to a silver coin, yet you would still feel the galaxy's pull, steady and sure. Estimates whisper of a total mass around 1 trillion suns, and most of that weight is hidden in this unseen sphere. The halo dominates, wrapping around the shining core like a vast cocoon. Within it move ancient stars, survivors from the galaxy's earliest times, and clusters of hundreds of thousands of suns bound together like frozen fireworks. These globular clusters trace long, stretched orbits, looping through the halo's quiet domain. Satellite galaxies, too, drift through its depths. Small companions pulled into its gravity well, trailing thin ribbons of stars called tidal streams. They move as if along invisible lanes, their shapes bent by the same unseen hand. The halo's form is not perfect symmetry. It may be slightly squashed, perhaps shaped like an ellipsoid rather than a sphere. Some models imagine it triaxial, a subtle geometry of balance and stretch. Its density fades with distance, thinning outward until its reach merges with the broader web of cosmic matter. Yet even at the edges, its influence holds, binding stars that would otherwise wander free. The halo does not glow, but it defines the galaxy's boundary, giving it coherence amid the cosmic sea. Whatever its nature, perhaps particles beyond the grasp of any laboratory, it acts with practical grace. It governs the outer rotation, ensures that distant gas remains tethered, and frames the conditions by which galaxies form and merge. When new gas drifts inward, it does so through the gentle gradient of the halo's gravity, shaping how stars will be born in the future. It is a silent architect, arranging the conditions for stability without ever revealing its face. And in this lies a kind of reassurance. Things hold together because something holds them. On Earth, weight is what you feel through the soles of your feet, the steady resistance of the ground. In a galaxy, weight is the pattern of motion, the curve that refuses to fall. The unseen mass offers the same comfort as gravity beneath your chair, proof that what seems empty is, in truth, full of strength. The halo is not merely structure, it is persistence. It also remembers, through its depths, past relics of earlier epochs, remnants of galaxies consumed long ago. Their trails still wind through the dark, delicate as breath on glass. Subtle ripples in these streams can reveal encounters with small clumps of dark matter, tiny knots of gravity that never formed into stars but continue to drift like ghosts. Astronomers trace these ripples, searching for signatures of collision and passage, clues to the hidden architecture of the halo. Even the Milky Way's disk is not perfectly still. It warps at the edges, curling slightly upward and downward like a sheet caught in slow motion. This may be the tug of massive companions or the echo of the halo's uneven mass. The sun itself moves gently up and down through the galactic plane, a quiet oscillation lasting tens of millions of years. Its motion, too, is tuned by invisible weight, guided by a presence that fills the space between stars. Imagine scaffolding in the dark. You might not see its beams, but when you watch how people move, where the lights align, where the floors stay level, you sense the frame that supports it all. Dark matter functions like that, unseen framework, wide and patient. It doesn't call for attention, yet without it, the luminous parts would drift apart. Stars would fly too quickly, galaxies would scatter, and the great cosmic structures would unravel. The halo allows galaxies to gather, to merge without tearing themselves to pieces. It cushions collisions, absorbs momentum, and slows the violence of cosmic time. When two galaxies meet, their stars rarely crash directly. Instead, the dark halos merge first, guiding the luminous centers toward a new harmony. It is this patience, the patience of gravity spread thin, that lets the visible universe unfold in slow endurance. And still, the night continues. The unseen weight hums beneath every shining spiral, beneath every calm rotation. We are held by it, carried through a field that never fades. If you were to drift beyond the stars, away from the disk and its glittering arms, you would not fall into nothing. You would still feel the galaxy's heartbeat, transmitted through the dark. The halo would hold you, as it holds everything else, in a cradle of invisible mass. Somewhere within that quiet field, the Milky Way breathes. Its luminous disk turns like a lantern flame, steady against the wind of time. The dark halo surrounds it, patient and unseen, the hidden weight that keeps the light from scattering. It is the gravity of memory, the curve of belonging, the slow reassurance that even in proof, the deepest dark structure remains. And as the tide of motion flows on, the stars trace their endless arcs through a gravity older than sight. What holds them is not light, but something quieter, a gravity without color, a presence without form. And through that presence, galaxies endure, gathering their brightness in the calm, invisible embrace of the dark. Far from the Milky Way's bright midplane, the light loosens into a thin halo. Stars are spread sparsely here, older on average than those in the disk, and poor in heavy elements. Their atmospheres hold little iron or calcium compared to the Sun, a sign that they formed when the universe had produced only a few rounds of enrichment. Many follow tilted, elongated paths that carry them high above and far below the plane, spending only brief moments cutting through the crowded regions we know. Their motions look irregular at first glance, but when traced carefully, they settle into patterns that reflect how they arrived. Globular clusters roam this realm as durable companions. Each is a tight sphere, containing hundreds of thousands of stars, gravitationally bound and remarkably long-lived. Many clusters are more than 10 billion years old. Their stars share similar compositions and ages, making each cluster a controlled sample from deep time. They orbit the galactic center on paths that can be steeply inclined, sometimes plunging through the disk and then coasting back out into the quiet. When one passes close to the Milky Way's central mass, tides strip a few stars from its edges. Those lost members do not vanish. They draw out into extended trails that keep the cluster's story legible. Across the halo, such trails appear again and again. Long, narrow streams of stars lace the sky, remnants of dwarf galaxies and clusters that wandered too close. Their widths are small compared to their lengths, which can stretch across large portions of the sky. The Sagittarius dwarf galaxy provides a present example. As it orbits, the Milky Way's gravity pulls it apart, and its debris wraps around us in broad arcs. Similar structures carry other names and histories, but they share the same origin, a smaller system captured, stretched, and slowly folded into the larger whole. The halo is not a smooth fog. It is stitched with these rivers. Deeper signatures lie in the motions and chemistry of individual stars. Astronomers combine positions, velocities, and elemental abundances to sort stars into coherent groups. Members of a dissolved dwarf galaxy often share a distinct chemical pattern ratios of elements that reflect the size and star formation history of the original system. When those stars also move together through space, the case strengthens. One ancient event stands out in this mapping, a major merger early in the Milky Way's life that brought in a large fraction of the halo's present stars and stirred the young disk. The footprint remains in the stars' orbits and in their low metallicities. The disk heated and thickened. The halo gained new members. The combined system settled, and evolution continued from there. The halo extends far beyond the visible edge of the disk. Its density falls with distance, but its reach is vast. measured in hundreds of thousands of light years. Out there, stars are few and faint, moving on orbits that can take billions of years to complete. Their slow passages turn the halo into a long archive. The outermost members likely arrived during early accretion, when the Milky Way grew by drawing in small companions. The inner halo shows a mix: debris from ancient mergers interleaved with stars ejected from the disk by past interactions. The boundary between inner and outer is not a hard line. It's a gradual change in composition, motion, and memory. Metal content ties the halo to the universe's early chemistry. Heavy elements form in stars and spread through explosions and winds. A low metal fraction marks stars born before many such cycles had occurred. Some halo stars are extremely metal poor, with iron abundances 1,000 times lower than the Sun's. They carry unusual abundance patterns in lighter and heavier elements, signatures of rare nucleosynthesis events, massive star deaths, neutron-star collisions, or peculiar early supernovae. Those patterns give clues to the first generations of stars that no longer exist. In that way, a single halo star becomes a witness from a time we can no longer observe directly. Globular clusters also carry chemical stories. Many show slight variations in light elements among their stars, evidence of internal processing and multiple episodes of star formation long ago. Yet their iron content remains tight, unlike the broader spreads found in dwarf galaxies. That difference helps astronomers tell whether a stream came from a cluster or a small galaxy. The galaxy's gravity writes the geometry. The chemistry writes the origin. Place both together, and families emerge from what first looked like a crowd. The halo's structure resembles delicate work traced over and over. Think of faint lines on a winter window where fine paths cross without confusion. Gravity drew these lines over billions of years, each pass recording a capture, a passage, a loss of a few stars at a time. The image is quiet, but it is not static. Streams gradually phase mix, spreading until they are hard to distinguish. Clumps disperse, shells expand and fade. Before they do, careful surveys catch them and add their shapes to the ledger. Modern mapping made the faint crown far less mysterious. Precise positions and motions allow astronomers to compute orbits and find groupings with shared tracks. Spectrographs supply elemental abundances that sort stars by origin. Wide-field imaging reveals long, dim structures across the sky. Together, these tools turn what once was a vague glow into a detailed record. A star with a low metal content, a particular ratio of magnesium to iron, and a velocity pointing along a known stream can be placed in a near-certain family. Another with different chemistry and a more plunging orbit might trace a separate event. The halo becomes a family album, and the captions grow clearer. Memory is the halo's quiet theme. Each star retains the conditions of its birth in its composition. Each path keeps the imprint of how and when capture happened. The disk shows the ongoing household: gas cycling, spiral patterns, steady star formation. The halo shows who moved in long ago, where they came from, and how the home expanded around them. Even the empty-looking spaces contribute, defining the scale of the galaxy's gravitational reach and revealing where dark matter must lie to hold the farthest orbits. Globular clusters emphasize resilience. They survived early tides, long crossings, and countless passages through the disk. Some have lost mass and now trail twin streams forward and back along their orbits. Others remain compact, with only subtle signs of erosion. Their steady presence offers anchors across the halo, points where distances and motions can be measured with confidence. From those anchors, the larger pattern sharpens. Not all halo stars were accreted. A fraction, likely formed in the young Milky Way, and were later stirred into high orbits during past interactions. Their chemistry looks more like disk stars, but their paths carry them well above the plane. This mixed origin explains why the halo is not a single population. It is the sum of histories: early build-up, later mergers, gradual heating, and continual pruning at the edges of clusters and satellites. Occasionally, a star arrives, moving fast enough to leave the galaxy entirely. These hypervelocity travelers are rare, but they add a final grace note to the halo's range. Most halo stars remain bound, turning slowly in their wide loops. A few, accelerated by interactions near the center or within dense clusters, carry the Milky Way's story outward into intergalactic space. Even their departures help test the total mass of the galaxy, since escape speed depends on the halo's depth. The faint crown does not shine to draw attention. It steadies the galaxy by extending its mass and preserving its past. When you look up on a dark night, the band you see is the disk, viewed from within. The halo is harder to notice. It reveals itself in careful catalogues, in subtle correlations, in streams traced star by star, and yet it holds a truth that eases the mind. Growth leaves records, and records can be read with patience. In that patience, memory becomes map. As the hush deepens around the plane, we know the halo's threads guide us outward, and the path ahead loosens into the wider dark, where the Milky Way's history thins to its earliest notes, inviting the next quiet step. Under the dark quilt of interstellar space, there are regions so cold that even light seems to hesitate before entering. Within these frozen sanctuaries, vast clouds of gas and dust drift in near silence, the birthplaces of stars. These are the giant molecular clouds, the soft breath of the galaxy, holding temperatures just a few dozen degrees above absolute zero. Hydrogen reigns here, not in its atomic form, but as bonded pairs, H2 molecules, whispering together in the dark. Dust grains mingle among them, small and unassuming, yet capable of shaping destinies larger than themselves. Shielded by their own shadows, these clouds keep the warmth of starlight out, allowing their interiors to grow colder, denser, quieter still. Inside these clouds, the air, if one could call it that, is stirred by turbulence, a gentle churning driven by ancient galactic tides and the ghostly pull of magnetic field. Lines of magnetism thread the darkness, invisible scaffolds guiding the slow ballet of particles. Every ripple, every subtle compression becomes a promise. Over countless years, gravity begins its patient work. It does not rush, it waits, it gathers. Small knots of gas, denser than their surroundings, start to pull in more material. These pockets, known as cores, grow heavier until gravity outweighs the internal pressure trying to keep them apart. Collapse begins slow at first, then unstoppable. As a core contracts, it spins. Conservation of angular momentum keeps the dance balanced. The collapsing gas flattens into a disk, thin and wide, a cosmic halo circling an unseen center. This is the protostellar disk, the cradle of a future star, and perhaps the planets that will one day circle it. Material streams inward, falling onto the forming star, while twin jets of gas shoot out from the poles, narrow and brilliant. The jets clear paths through the surrounding cloud, carving long tunnels through the darkness. Somewhere inside, deep within the protostar, pressure and temperature climb until hydrogen nuclei begin to fuse. A spark ignites fusion, the quiet fire that defines a star's life. What began in ice and silence becomes light. Across a spiral galaxy, these nurseries draw faint, luminous outlines along the arms. As clouds drift into the denser ridges of the spiral pattern, shockwaves squeeze them gently, compressing the gas, pushing it past the threshold of instability. The arms are not solid structures, but moving waves of density, and as gas flows through, it is pressed and cooled, nudged toward birth. Where massive stars emerge, their radiation reshapes the darkness. Ultraviolet light pours outward, searing the surrounding gas, carving bright cavities and glowing rims. Yet behind those glowing edges, new stars still form in secret, shielded from the harsh light by thick curtains of dust. To human eyes, much of this process would remain invisible, but infrared light can pierce the dust, revealing the warmth of clustered young stars buried within. Telescopes tuned to these wavelengths uncover what the eye cannot, the hidden fire behind the veil. Radio waves, longer still, trace the cold lanes of gas. Molecules like carbon monoxide whisper their presence through these frequencies, mapping the flows and filaments that thread through galactic space. And the chemistry here is subtle, evolving. Heavy elements, the carbon, oxygen, silicon forged in earlier generations of stars, act as tiny radiators. They help the gas cool, letting it collapse more easily. The more cycles a galaxy has lived, the more efficient its star formation becomes. Dust, once the ashes of dying suns, becomes the womb for new ones. There is tenderness in this process, a quiet symmetry of endings and beginnings. A galaxy of hundreds of billions of stars owes its future to the chill of these small hidden chambers. Even our sun, bright and singular to us, was once one ember among many in such a nursery. Around it, siblings were born, scattered now across the spiral arms, their kinship remembered only in chemical fingerprints. The dust that once obscured their light was never an obstacle, but a caretaker. Every grain served as a surface for molecules to form, as a cooling agent for collapsing gas, as a shield from starlight, too intense for fragile beginnings. In the universe's most delicate work, dust is both the midwife and the blanket. There is a hush in these clouds reminiscent of winter air, when the world feels muted and sound carries farther. Within a molecular cloud, this hush is literal. Molecules move sluggishly, collisions are rare, energy scarce. Yet inside that quiet transformation proceeds. The collapse of a single dense core can take hundreds of thousands of years, a slow breath drawn over geological time. Around it, other pockets may remain stable or begin to stir. The newborn stars, once ignited, send shockwaves and radiation outward, stirring turbulence that both halts collapse nearby and ignites it elsewhere. One region quiets while another awakens. Feedback becomes the rhythm of creation, a balance between destruction and renewal. The result of this balance is a remarkable consistency. No matter where one looks in the galactic disk, the distribution of newborn stars by mass, the stellar initial mass function follows nearly the same pattern. Most stars are small, faint, and long-lived. A few grow massive and bright, shaping their neighborhoods and dying young. This recurring proportion seems written into the physics of cold gas, turbulence, and gravity, as if the universe hums the same tune in every arm and every epoch. From cloud to cloud, from galaxy to galaxy, the pattern endures the quiet agreement of matter and motion. Over time, the cycle continues. Clouds form, stars ignite, winds blow, and new clouds condense from the ashes. The galaxy does not hurry. It turns, patiently, a spiral clockwork renewing its own light. In each round, the same. Transformation unfolds cold breath, turning softly into firelight. The balance of elements shifts, the dust thickens, and yet the tenderness remains. What begins in stillness always returns there, after the flare of fusion fades. Even in its vastness, the universe tends to its own beginnings with care. And so, beneath the grand sweep of stars, it is the cold that first gives permission for warmth, the silence that invites sound. In the dim molecular chambers of space, every flicker of starlight we see was once an invisible tremor, a whisper of gravity in the dark. The night sky, serene and infinite, is a record of these small awakenings. As the tide of the galaxy drifts on, the pattern repeats, a slow exhale of light into the deep, and another breath of darkness drawn in, preparing the next generation. Massive stars burn through their lives in brilliance and haste. Their cores crush lighter elements into heavier ones, oxygen, silicon, iron, until the pressure within can no longer resist collapse. Then comes release. A supernova unfurls in seconds what took millions of years to build. In that moment of destruction, creation begins again. The explosion throws out the heavy atoms forged inside, scattering them through surrounding space like seeds in the wind. Those fragments of brilliance drift outward, cooling, mixing, and waiting to join new clouds. Less massive stars follow gentler paths. In their elder years, they shed outer layers, rich with carbon and nitrogen, letting them drift into the interstellar medium. Together, these ends compose a cycle, death feeding the next beginning, ash turning to clay for worlds not yet born. The galaxy's air, its interstellar medium, isn't empty. It's a shifting ocean of gas, dust, radiation, and magnetic whispers. When supernovae go off within it, their shockwaves expand like ripples in a pond, sweeping material into great arcs. Along the edges of those shells, gas is compressed, sometimes enough to ignite new stars. The remnants of one generation prepare the next. This chain of cause and renewal spans the Milky Way. Explosions setting off creation, creation sowing future explosions, each link glowing for a time before dissolving. Astronomers trace these events by their scars, filaments, cavities, and shells, tens of light years wide, silent now, but marked by the patterns of release. Where massive stars are born together, their combined energy sculpts enormous caverns. Stellar winds, streams of particles moving at hundreds of kilometers per second, clear the surrounding gas, leaving a bubble that grows until it breaks through the disk itself. The hottest gas can escape upward into the halo, venting energy and heavy elements in plumes that rise thousands of light years before cooling and falling again. This galactic fountain, as it's called, keeps the Milky Way breathing. Outflow and inflow, heat and cool, all in rhythm. What goes up eventually returns, denser and ready to start another round of star birth. In this quiet balance, the galaxy sustains its long life. Within that cycle lies chemistry. The elements born in stars are not just decoration, they are potential. Without oxygen, there would be no water. Without carbon, no cells, no minds to observe the stars that made them. Astronomers call the abundance of these elements metallicity. Galaxies with high metallicity have lived longer, recycling their matter many times. Younger galaxies, still sparse in heavy elements, glow with the simpler light of hydrogen and helium. The Milky Way's current mix tells a story of maturity. Billions of stars living and dying, layering complexity over time until the dust itself holds the chemistry for life. Supernovae also send out invisible travelers' cosmic rays. These charged particles race through space, bending along magnetic fields, influencing how gas cools and collapses. They carry energy where radiation cannot, and they alter molecules in dense clouds, nudging chemistry forward in places where starlight never reaches. Their paths weave unseen between the stars, part of the same cycle of cause and consequence. Even in their silence, they shape the conditions for what comes next. Energy from these stellar deaths doesn't just disrupt, it regulates. Without feedback, every cool cloud would collapse at once, turning the galaxy into a brief, furious blaze that would soon exhaust its fuel. Instead, Supernovae and winds return energy to the medium, heating some regions, stirring others, ensuring that star formation proceeds in measured waves. This balance is the Milky Way's patience, its way of surviving billions of years without burning itself out. Between each burst of formation lies rest. Between each storm, a calm that allows the next generation to gather. Picture a wide field after a summer storm. Some patches lie flattened by wind and rain, others glisten, revived. Puddles reflect the sky, and in the damp soil, seeds stir unseen. The galaxy's disk holds that same look on a cosmic scale. Supernovae are its storms, their shock waves flattening some regions while awakening others. The gas clouds that survive grow dense, enriched, ready. Light returns in new stars, fed by what the storm left behind. The destruction is never final. It's part of a rhythm that sustains beauty. These processes span distances too vast for the eye to imagine. A supernova shell may expand for hundreds of thousands of years before fading into the background. The metals it carries may take tens of millions more to cool and settle into new clouds. Then, slowly, gravity pulls those atoms back together, forming stars and planets. Some of that matter, iron in blood, calcium in bone, finds its way into living forms. Every breath we take recycles the memory of stars. Every element heavier than helium once burned in a stellar heart or flew outward from a dying sunday. When astronomers say we are made of stardust, it isn't poetry. It's quiet accuracy. Over time, this endless recycling shapes the Milky Way's texture. Regions of dense molecular gas trace the spiral arms, each one punctuated by knots of newborn clusters. In between lie superbubbles and chimneys where older stars once lived. The contrast, birth beside absence, silence beside light, is part of the galaxy's design. From above, the Milky Way looks alive, pulsing with warm dust and cool gas, its arms breathing in and out in slow succession. Every stage of stellar life is visible somewhere within its reach, from the glowing nurseries to the faint ashes of past giants. The emotional truth beneath the science is renewal. Nothing in the disk is permanent. Stars come and go, clouds assemble and disperse. Even the elements themselves move between states, frozen, fused, freed again. What remains, constant, is the pattern. Transformation, feeding, transformation. For a galaxy, endurance means change. For us, it means understanding that creation often hides in collapse, that endings can be gentle beginnings written in another form. As the light of countless supernovae drifts across the spiral arms, the Milky Way's quiet breath continues. Somewhere, a new cluster forms in the shell of an ancient blast. Somewhere else, old stars prepare to give their final gifts to the dust. The field, after the storm, glows once more. And in that long rhythm of loss and renewal, the galaxy hums softly, a patient, luminous heart that never forgets to begin again. Far out from the crowded heart of the Milky Way, the disk no longer lies flat. It lifts gently on one side and dips on the other, like a sheet of silk caught in a slow breeze. This bending, this quiet asymmetry, is called the warp. It becomes most visible not in the stars, but in the gas, the ocean of neutral hydrogen that stretches farther than the starlight itself. Radio telescopes trace that hydrogen, mapping its faint glow across the sky. The pattern they find curves upward in one direction, downward in the opposite, forming a slow twist that wraps the galaxy's outer rim. The stellar disk follows that bend too, though more modestly. Stars are heavier, more resistant to change. Gas is light and free, exaggerating every ripple. Together, they draw the galaxy's edge into a shallow wave, hundreds of light years high, a gesture that marks both motion and memory. The reason for this graceful tilt may lie close to home. Just beyond the Milky Way's edge, drift the large and small Magellanic Clouds, two companion galaxies, bright enough to be seen from the southern hemisphere with the naked eye. They orbit us like distant dancers, their combined mass tugging softly at our disk. Their latest approach, in cosmic terms, was recent, perhaps within the last few 100 million years. That encounter may have sent a wave through our galaxy's outer layers, a wave still unfolding today. The gas, being supple, felt the pull first. The stars followed, slower but steadier, bending under the same invisible rhythm. And somewhere deeper, the dark matter halo, the vast, unseen sphere that envelops the Milky Way, helped decide how long that wave would endure. For the galaxy is not alone in its darkness. It moves through a sea of smaller substructures, clumps of dark matter that leave subtle fingerprints as they pass. One may have brushed the outer rim long ago, stirring the disk just enough to start a wobble. The shape of the halo, perhaps stretched, perhaps slightly tilted, helps these ripples persist, holding the warp like a memory written into space. To trace its form is to glimpse the unseen framework that supports everything. When astronomers model how such disturbances travel through the disk, they can infer the hidden mass of both the halo and the nearby satellites. The warp becomes not only a feature, but a clue, a way to weigh the invisible. Yet, the galaxy's outer reaches are not just warped, they are uneven. On one side, the disk appears thicker, the light more diffuse. Spiral fragments there differ in length and brightness, and the count of stars is slightly lopsided. These asymmetries are quiet, but persistent. They tell of encounters, not fragility. The Milky Way, like all disks, records its past in motion. When something disturbs it, a passing satellite, a shift in gravitational balance, the whole structure flexes and rings, like a great bell struck in the dark. The vibration may fade from sight, but it continues in motion, each rotation carrying the echo a little farther. Through this lens, the warp becomes a symbol of endurance. It does not interrupt the galaxy's essential work. Stars still form in the outer arms, gas still flows inward, and most orbits remain serene and regular. The warp bends the structure, but not its rhythm. It adds character to the spiral, a sign that even in vast systems, balance is dynamic, not static. The disk breathes, adjusts, and continues. The very deformations that mark its history also reveal its strength, a flexible order that can absorb disturbance and turn it into quiet harmony. Astronomers read these motions as we might trace folds in fabric. By modeling the speed and depth of the warp, they can estimate how much mass the halo must contain to hold the disk steady. They can measure how strongly the Magellanic Clouds tug and how far their influence reaches. The shape of the bend tells them about time. How many rotations have passed since the side disturbance began? How the wave has aged and spread? Every curve and tilt becomes a piece of evidence, a whisper of the Milky Way's ongoing dialogue with its surroundings. It is not only theory that connects these pieces. The sky itself holds another sign, the Magellanic Stream. This is a long, ribbon-like trail of hydrogen gas that stretches behind the Magellanic Clouds for hundreds of thousands of light-years. It arcs across space like a faint scar of motion, marking the path of the clouds as they circle us. That stream is part of the same story. Gas stripped from our companions flows behind them and, over time, some of it will fall toward the Milky Way again. The galaxy's warp and the stream's ribbon are linked gestures of gravity's endless exchange. Where matter pulled away, one day returns as fuel for new stars. Think of a hand brushing past a hanging tapestry. The fabric sways, forming a slow-moving wave that glides from one side to the other. The pattern woven into the cloth remains unchanged, but for a moment it seems alive, breathing with motion. The outer Milky Way behaves in much the same way. The structure endures, though it bends. Its curves carry the memory of touch, the reminder that even distant companions can leave gentle imprints. Over time, the wave quiets, settling back toward symmetry, yet traces linger, like faint ripples after a breeze. In this vast stillness, every movement has meaning. The warp is not a flaw but a signature, a mark of cosmic conversation. The galaxy listens and responds, folding slightly, then unfolding again. Even as its rim tilts, its center remains steady, turning as it always has. From our vantage point within one of the spiral arms, the bending is almost imperceptible, revealed only by careful mapping. But through the radio glow of hydrogen and the slow drift of starlight, we can sense it, the rim rising, the rim dipping, the silent wave that circles the edge of home. Gravity keeps the choreography in motion. The Magellanic Clouds continue their orbit, the dark halo hums beneath the stars, and the galaxy's disk keeps circling, a dancer with one foot slightly raised. The warp endures for hundreds of millions of years, fading only when new rhythms replace it. In its persistence, there is resilience, the calm assurance that even when bent, the Milky Way never breaks. Its rim may tilt, its light may waver, but the great rotation continues, steady as breath, turning endlessly beneath the slow, listening sky. Not every star obeys the quiet rhythm of the galactic dance. Most drift in the same grand direction, tracing the spiral arms like patient travelers on a shared current. But every so often, one strays. It sprints across the dark, a lone spark against the calm rotation, moving so fast that gravity's tether begins to loosen. These are the restless ones, hypervelocity stars, rare wanderers racing through the halo, bound for the emptiness beyond the Milky Way. Their speed is no gentle drift, but a slingshot's release, a farewell drawn out over millions of years. Some of these runners were born in pairs, orbiting each other tightly near the galactic center. When their path drew too close to the supermassive black hole, the system met its undoing. One star was pulled inward, consumed entirely by the gravity well, while the other was hurled outward in recoil. Its companion's loss became its propulsion. Freed from the pull that once held it close, it soared outward faster than any wind the galaxy could offer. Others gained their speed through celestial collisions, three-body encounters, where gravity's complex dance ends with one partner ejected. And sometimes, when a massive star explodes in a supernova, its surviving companion finds itself suddenly alone, unbound, and flung away by the force of its partner's death. Each hypervelocity star carries a record of its escape, written in its motion. Astronomers trace their paths through space, like trails of light on a long exposure, finding where they began and what event set them free. Their orbits reveal ancient dramas no one witnessed, close shaves with the galactic heart, sudden separations, silent expulsions into the void. In their speed, there is both violence and grace. The energy that freed them was immense, yet their journey now unfolds in stillness, drifting for billions of years through the outer halo, surrounded by near-perfect silence. And then there are others who move against the current, entirely. Far from the center, some stars trace backward orbits, traveling in the opposite direction of the Milky Way's spin. They are not rebels by choice, but remnants of another time and place. Many belong to small galaxies long ago absorbed by the Milky Way's gravity. As these dwarfs were swallowed and stretched apart, their stars were set adrift, still carrying the momentum of their origins. Their paths became threads woven through the main rotation, distinct, but now part of the larger fabric. Chemically, these immigrant stars tell their stories too. Their light carries the fingerprints of the elements forged in their birthplaces, different mixtures of iron, magnesium, and calcium than those found in native stars. By reading those signatures, astronomers can identify which stars were once neighbors, even if they are now scattered across thousands of light years. The chemistry becomes a quiet dialect of memory, revealing which systems were born together and which were merely passing through. Curiosity anchors this study of movement. Every orbit, every trajectory is a clue to something older, a message carried through time and distance. Astronomers trace the paths of these strays and compare their compositions, reconstructing collisions and mergers long vanished from sight. The Milky Way's shape, its slow evolution, its scars and seams, all become visible in this motion. Stellar streams arc across the halo like faint handwriting on dark paper, marking where dwarf galaxies once looped before dissolving. Clumps of stars that share both chemistry and motion reveal the remains of ancient associations, families born together before the tides of gravity pulled them apart. Even within the calm plane of the disk, stars drift and migrate. Over billions of years, gravitational nudges from spiral arms and giant clouds push them inward or outward, scattering siblings across wide spans of sky. The Sun itself may have been born alongside hundreds of others, all now scattered beyond recognition. Yet their chemical bond remains, a faint trace waiting to be matched. Through this tagging, astronomers can rebuild lost kinships, finding families of stars that no longer move together but still carry the same elemental memory. It is a cosmic archaeology of motion and light. Every stray, every backward mover becomes part of a greater map, one that shows not just where the stars are, but how they came to be there. These movements reveal the galaxy's history in slow unfolding, the accretion of smaller systems, the restless energy of central gravity, the quiet diffusion of families into the crowd. The Milky Way's past is not told in written words, but in arcs and velocities, in orbits that curve like brush strokes on a vast canvas. Imagine footprints across a wide snowfield. Some stride in unison, steady and aligned. Others cross at sharp angles, moving in their own direction. From above, the pattern reveals stories who walked together, who came later, who turned away. The galaxy's stars leave just such a record. The strays are those unexpected footprints, making the common flow clearer by contrast. Through them, the calm order of the rest gains meaning. In their difference, these stars teach about belonging. They show how systems evolve through encounter and loss, through capture and release. They demonstrate what gravity can sculpt and what it can let go. Even the rarest wanderer, speeding into intergalactic space, carries with it a fragment of the Milky Way's heart. And still, amid all this motion, the galaxy remains serene. Its spiral arms turn slowly, gathering and dispersing. The majority of stars keep their patient rhythm, orbiting in measured harmony. Yet the strays matter precisely because they do not. They are signs written in motion, reminders that even in the universe's great calm, there are stories of departure, reunion, and return. As the night continues, those faint travelers move ever outward, their light dimming with distance. Somewhere beyond the halo, they drift between galaxies, carrying the history of one into the silence of another. In their loneliness lies a kind of beauty, the mark of motion unending, the record of a galaxy that breathes, remembers, and still lets some of its children go. Each star carries within its light a trace of where it was born. Its atmosphere, thin as breath, holds a quiet record of the cloud that once cradled it. The elements within iron, magnesium, silicon, oxygen stand in ratios that do not change through the ages. They are a kind of ink, written when the star began to shine, sealed in heat and gravity. Every spectrum, when split by a prism, becomes a letter from the past. The faint lines tell of hydrogen and helium in abundance, and of heavier elements measured in whispers. Astronomers call these metals, though many are not the kind we think of as metal at all. To them, a star rich in iron is a child of later times. A star nearly without it is something older, something that remembers the dawn. Extremely metal-poor stars are among the oldest things the galaxy still holds. Their iron content can be less than 100,000th of the Sun's, so little that it barely registers. They are fossils of a cosmic morning, when only the first massive stars had lived and died. Each of those giants burned fast and brief, ending in a supernova that scattered its contents into the void. The next generation formed from those remnants, carrying a faint trace of that first enrichment. In some of the oldest survivors, astronomers find odd signatures, one star rich in carbon, but poor in everything else. Another touched by rare elements like europium. These patterns reveal single events, perhaps one explosion's ashes, or the residue from a neutron star collision that sprayed gold and platinum across space. In the halo of the Milky Way, these ancient objects drift slowly along vast, eccentric orbits. They pass far above and below the galactic plane, taking hundreds of millions of years to circle back. Their motion is loose, graceful, and unhurried, as if age itself had smoothed their paths. Down nearer the plane, in the thick disk, older stars move in a denser weave, their chemistry distinct from the thin disk that contains most of the Sun's contemporaries. Here, the balance of elements shifts the proportion of alpha elements to iron higher, the signature of a faster, earlier era of star birth. By measuring many thousands of stars, each one with high-resolution spectra, astronomers can begin to sort them into families. It is called chemical tagging, a method that treats elemental ratios as fingerprints. Two stars with nearly identical chemical handwriting likely came from the same molecular cloud, even if time has carried them far apart. Combined with their positions and motions, these signatures reveal hidden kinships across the sky. Groups once bound together are recognized again, their shared origins traced through the noise of modern structure. What was once chaos begins to show order, a pattern of birth, dispersal, and reunion. Each measurement adds a line to the galaxy's autobiography. A hyper-metal-poor star speaks of an age when the universe held almost nothing but hydrogen and helium, and when a single supernova could tip the balance enough to allow the next spark of fusion. Others, marked with rare heavy nuclei, record events more dramatic, the merging of neutron stars, their collision releasing both gravitational waves and new matter. The elements they create, gold, platinum, uranium, scatter outward, mixing into new gas, settling eventually into planets and veins beneath future mountains. Every ring on a finger, every atom of iron in blood, was once part of this slow inheritance. The feeling such knowledge brings is not triumph, but reverence. To look at one of these stars through a telescope is to peer at a survivor of a vanished world. Its light began before there were continents, before even the sun existed. It has watched galaxies collide, seen companions fade, drifted through epochs of calm and turbulence without changing its message. In it, the ratio of one element to another is steady, immutable. Like handwriting on ancient paper, it endures even as everything else moves. Astronomers read these letters not with eyes but with instruments, splitting light into hundreds of colors and studying the depth of each narrow line. A deep line means an element abundant, a faint one, rare. Through these patterns, they can tell not only the composition, but the story, how quickly the galaxy enriched itself, which regions gave rise to which populations, how mergers stitched foreign stars into the Milky Way's body. Each spectrum is a voice, and together they become a chorus describing the growth of complexity, from simplicity toward diversity. It helps to imagine an old wooden box filled with letters in many hands. Some are written in ancient ink, almost faded away. Others are newer, darker, confident. A few are written in strange languages, the remains of other cultures now long folded into our own. Sorting them requires patience. You compare phrases, count the turns of speech, and slowly realize which came first, which borrowed from another, which belonged to the same family. The galaxy's archive is like that. Its letters are made of light, its handwriting of atoms. They move through space, glowing softly, carrying news from billions of years ago. Within this correspondence lies the story of our own materials. The calcium in bones, the iron that colors blood, the carbon that builds every cell. Each atom has an ancestry older than the Earth, drawn from clouds enriched by countless deaths and rebirths. The stars do not write to us directly, but the record is there for those who learn how to read. As the night deepens, that thought brings a kind of peace. We are built from memory, from the slow accumulation of what the universe has written into its stars. The halo holds its oldest letters still, drifting like quiet lanterns, their messages steady across unthinkable time. To read them is to listen to the first whispers of creation and to feel just faintly the patience with which the galaxy has kept its archive safe. And as the sky turns overhead, more letters rise, each with its own story, each with its own ink. Together they tell how the Milky Way grew from fragments into a single home of light. The record is not finished, but still being written, word by word, in the glow of every new star that forms. On the edge of the night sky, a faint spiral glows our cosmic neighbor, the Andromeda Galaxy. Its light has been traveling toward us for more than 2 million years, yet even now it drifts closer, pulled by a shared gravity that binds the small family of galaxies we call the local group. On human timescales, it seems frozen, but on the deep stage of the cosmos, it is already in motion, a slow approach, written into the dance of mass and distance. One day, far beyond any horizon we will see, the Milky Way and Andromeda will meet. That meeting won't be a crash in the way our minds imagine impact. Space between stars is vast. Even when galaxies merge, most suns never touch. They pass through, guided by the invisible geometry of gravity. Still, the meeting will not be silent. Tides will stretch both disks, pulling out long ribbons of stars, tidal tails curling like silk in water. Orbits will twist, and some stars will be flung outward, settling in the extended halo. Others will fall inward toward a new shared core, where two supermassive black holes will slowly spiral together, their motion releasing waves through the very fabric of space-time. The result will be a single, rounder galaxy, softer at the edges and richer in memory. The timescale humbles the mind. The first close pass lies billions of years ahead, followed by long arcs apart before final coalescence. Between acts, each galaxy will stretch and breathe, carrying streams of stars across deep space. Gas clouds will meet, collide, and compress. For a while, this encounter will reawaken star formation, lighting fresh clusters along the new tidal bridges. In other regions, star birth will fade as gas is heated or expelled, pausing the rhythm until calm returns. The halo will grow wider and more layered, stitched with the remnants of both lineages. Such change sounds dramatic, yet it's not danger, it's evolution. Galaxies live by change. The Milky Way itself was built from dozens of smaller mergers, each one adding stars, gas, and motion to the whole. Every glow we see in the halo carries evidence of one of those ancient unions. Andromeda's approach is simply the next chapter, this time written between equals, Simulations trace the pattern. The first encounter tears spiral arms into long arcs. The second draws them back in new configurations. The last brings balance, a single elliptical body shining quietly at the group's center. Even then, stars will rarely collide. Gravity is a sculptor that prefers distance, not destruction. The emotional thread here is acceptance, an understanding that stability is only one note in a longer song. Just as the Earth's continents drift and merge over geologic ages, galaxies reshape themselves across cosmic ages. What we call the Milky Way is temporary, but the materials, the stars, and the elements it holds will endure in new form. When Andromeda's core begins to dominate the sky, the Sun's distant descendants, if any remain, will look up and see a view unlike anything we know, a neighboring galaxy's heart rising enormous on the horizon, glowing with tidal streams that span the heavens. It will not signal an end, only a different kind of sky. Gas dynamics will play their part. Where streams of interstellar medium intersect, density will rise and trigger bursts of star formation. Elsewhere, turbulence will scatter gas outward, and some of it will leave forever, enriching intergalactic space with heavier elements forged long before. The local group will simplify as its largest members merge. Smaller companions dwarfs like the Magellanic Clouds will either be absorbed or left to orbit the new combined mass. Over trillions of years, the remnant will fade into the calm of starlight, diluted by time, a single luminous oval, adrift in the cooling dark. To know this future is to practice cosmic patience. The times between each act stretch longer than the history of life on Earth. The era of mammals, of oceans, and language fits into a blink compared to the span between the first approach and the final settling. The universe writes in sentences billions of years long. We, reading one phrase, can only pause and feel the rhythm. Imagine two whirlpools drifting on a lake so wide you cannot see its shores. From above, they seem destined to meet soon. From the waterline, their motion is glacial, almost still. That's the scale of the Milky Way and Andromeda's approach. They have been falling toward one another since before our solar system formed, and they will continue until gravity's curve completes the pattern. Each rotation of the Sun around the galactic center brings them a fraction closer, an imperceptible motion that adds up across epochs. This knowledge doesn't unsettle, it steadies. It tells us that change, even vast change, can unfold in silence, with grace and order. The night sky's calm is not permanent, but it is generous, lasting longer than any heartbeat, any civilization, any memory. The galaxy we know will one day look different, its stars rearranged into a broader, quieter form. Yet the forces shaping that outcome are the same that hold us now: gravity, inertia, time, and the constant trade between motion and rest. In this slow embrace, no one hurries. The galaxies drift, respond, and reshape. Their meeting will end one story and begin another, as all endings do in the universe. The sky will change, but the laws will remain, simple and kind. And as the tide of time moves forward, we too are part of that long patience, the small consciousness within a galaxy learning to rest inside its own unfolding. A strip of starlight crosses the sky like a pale ribbon, and from within it, we try to see our home. Turning that shining band into a map requires more than wonder. It requires distance, motion, and patience gathered over years. The galaxy does not show its shape to us directly. We are inside it, moving along one of its arms. To build the picture, astronomers learn to measure tiny shifts, positions changing by fractions of a hair's breadth, seen from light years away. Spacecraft dedicated to this quiet work charted those motions with exquisite precision, down to micro-arc seconds, tracing how each point drifts across the heavens. From that accumulation of movement, structure emerges. The disk's gentle warp becomes visible. The bar at the center sharpens in angle, and long threads once blurred by guesswork separate into clear, winding streams. Velocity joins position to give life to the map. When starlight splits through a spectrograph, its lines shift slightly with speed, letting us hear the hum of orbits too slow for our senses. Layer those tones, and a pattern of resonance appears, regions where gravity's rhythm shapes paths, where spiral waves steer gas into lanes and trigger new stars. Each number adds a brushstroke. The Milky Way's flat face begins to curve into 3 dimensions, and what was once a smear of brightness becomes a living structure of depth and flow. Other instruments extend that sight beyond visible light. Variable stars, pulsing at regular intervals, serve as beacons. Their brightness and rhythm obey a known law. The longer the pulse, the brighter the star. By comparing apparent and intrinsic light, distances unfold, like measured steps across the dark. Radio telescopes tuned to 21 centimeters, a wavelength from neutral hydrogen, and map the skeleton of the disk where optical eyes see nothing but dust. Those waves trace bends and swirls far into the outer regions, revealing that the galaxy's plane itself rises and dips like a slow wave. Infrared observatories peer through that same dust, uncovering clusters still half hidden in their birth clouds and sketching the bulge's true shape beneath the haze. Each wavelength tells a truth that others miss, and together they weave a fuller portrait. Spectrographs on ground-based telescopes add chemistry to the coordinates. The atmosphere of a star carries the memory of its birthplace ratios of iron, oxygen, carbon, and magnesium. By comparing these chemical fingerprints with motion, astronomers group stars into families. Some formed together in the disk. Others came from smaller galaxies later absorbed. The map becomes not only spatial but ancestral, a record of where the Milky Way's pieces came from and how they assembled over billions of years. Billions of measurements, each a fraction of a second or a pixel, combine into a single coherent picture. No single observer could have gathered them. No single night could have held so many points of light steady. Yet through shared effort, the blurry becomes precise. Structures that once lived only in theory refine themselves. Spiral arms that seemed smooth reveal forked paths. Spurs appear where patterns split. Gaps that were dismissed as errors now show themselves as consequences of resonance and motion. The galaxy grows not larger, but clearer, its rhythms less mysterious for being drawn in numbers instead of ink. This is companionship made mathematical. Each instrument, each orbiting satellite, each ground telescope contributes its fraction of truth. Together, they act like friends, recounting a shared memory, each angle slightly different, yet all converging toward the same shape. The result is not spectacle, it is relief. To know our place, to replace uncertainty with understanding, is a kind of quiet comfort. The Milky Way ceases to be a fog of stars and becomes a home with corners, folds, and familiar turns. Imagine trying to trace a coastline through thick fog. You can't see the shore, but you can listen. You toss small pebbles ahead and wait for the sound they make when they strike rock or water. Each throw tells you a little, and many throws reveal the curve of the land. That is how our species maps the galaxy from within. Each measurement is a pebble tossed into the dark. The echoes come back as parallax, redshift, proper motion, or chemical line. Taken alone, they seem trivial. Gathered together, they describe the shape of an island vast enough to hold everything we know. The process is slow by design. It requires repetition, calibration, correction for the Earth's own movement, and a patience that spans generations. The Milky Way changes too, but not so quickly that it slips away before we finish our drawing. As the data accumulate, the picture gains subtlety. Faint streams of stars stretching through the halo, the tilt of the outer disk, the slightly twisted heart at the center. Each discovery refines, but none ends the work. There is always another layer of detail to add a deeper sample, a sharper measurement, a quieter tone in the cosmic song. And through it all runs an emotional thread of orientation. Humans have always looked up to understand where they are. In earlier times, constellations were enough familiar shapes linking stories across seasons. Now the same instinct expands to scales beyond imagination. We no longer map only the stars we see. We map their motions, their origins, their chemistry. In doing so, we locate ourselves in a structure that existed long before memory and will continue long after. The knowledge does not diminish the mystery, it settles it. What we learn from mapping the Milky Way is that belonging does not require centrality. We are not near the heart, nor at the edge, but somewhere calm between. From that vantage, the galaxy's luminous band across the night becomes both symbol and path. It's not merely beautiful, it's navigable by thought. When you next see that faint river, too of light, remember that it has been measured, traced, and understood, not to reduce its wonder, but to bring it closer. Its curves are the handwriting of gravity itself, patient and continuous, and we are one of the points within its script. The fog thins, the shoreline forms, and the map unfolds under a steady hand. Every coordinate is a whisper from a star, every whisper part of a chorus. Together they remind us that clarity can be gentle and discovery can hum instead of shout. As the night stretches on, the instruments keep listening, and the galaxy continues to reveal its shape, not all at once, but in soft increments, like dawn arriving through layers of quiet light. Between the Milky Way's bright arms lies a calmer span, a place not too crowded, not too bare. Here, the sky is steady. Radiation fades to a tolerable hush, supernovae are distant flickers, and tides are slow enough for orbits to stay round for billions of years. Astronomers call it the galactic habitable zone, not a promise, but a possibility. Life does not demand this address, but it thrives where time can linger. Nearer the galactic core, the light grows harsh. Stars pack close, explosions are frequent. Further out, in the cool outskirts, the raw ingredients for rocky worlds thin away. But here, halfway between heat and emptiness, the balance feels just right. Our solar system circles within this wide, gentle belt, about 27,000 light-years from the center, inside a small spur between larger spiral arms. The Sun completes a full orbit roughly every 220 million years, one galactic year. During that time, the neighborhood changes, but the tone remains calm. The Sun drifts through clouds of gas, passes above and below the galactic plane, and weaves between regions of different star density. Yet through all of this, the conditions for stability hold. The Earth stays lit but not scorched, close enough to a steady star, far enough from the fireworks of stellar birth and death that shake the inner lanes. That quiet matters. In denser regions, nearby massive stars often explode, bathing space in radiation that can strip atmospheres or reset chemistry. Here, such events are rare. The last few 100 million years have passed without a dangerously close supernova. It's not luck, it's location. The spiral arms host more bright, short-lived stars, and the gaps between them are gentler. Our orbit threads those gaps, crossing denser regions only occasionally. The Sun's path through the galaxy is like a boat drifting between waves rather than over their crests. The Sun itself likely began in a cluster, surrounded by hundreds of sibling stars. Over time, gravitational tides stretched that nursery apart, scattering its children across the disk. Some of those stars still carry the same chemical fingerprint to match, in ratios of oxygen, magnesium, and iron that betray shared birth material. Astronomers search for them now, tracing motions and chemistry to identify the Sun's lost family. Most have wandered thousands of light years away. Their separation is the natural price of galactic motion. Still, the idea that we are part of a dispersed group offers a quiet sense of kinship that outlives proximity. Gratitude is the feeling that anchors this place. Conditions here do not ensure consciousness, but they allow patience enough time for oceans to settle, continents to drift, atmospheres to breathe in cycles. Stability makes room for repetition, and repetition is what life needs. Water condenses, evaporates, and returns. Carbon binds and releases. The planet cools and warms in rhythms that never stray too far. These slow loops depend on a galaxy that neither overwhelms nor abandons them. Too many nearby explosions, and climate would flinch. Too little metal in the surrounding stars, and Earth might never have formed at all. The galaxy has not chosen kindness, it has simply offered space. The Sun's neighborhood contains stars older and younger, larger and smaller, but few so massive as to disturb the calm. Clouds of gas drift lazily, not dense enough to collapse rapidly. Interstellar dust, thin but steady, softens the sky. Even cosmic rays, those swift messengers from elsewhere, are moderated by the Sun's magnetic bubble before reaching Earth. These quiet layers of protection, galactic, stellar, planetary, make existence less fragile than it could be. Within them, chemistry had time to explore itself into complexity. Imagine living on a quiet side street that still connects to the main avenues when you need them. You hear the city's pulse, but not its alarms. The galactic disk has streets like that. Closer to the center, the lights never dim. Further out, everything spreads and thins. Our address falls between connected but calm. When you look at the Milky Way band overhead, you're gazing along those crowded avenues from the edge of one of its quieter lanes. The galaxy's traffic continues regardless. Stars form, drift, die, and return their material to space. The metallicity, the abundance of heavy elements, changes slowly as each generation enriches the next. That enrichment made rocky planets possible in the first place. The early Milky Way was mostly hydrogen and helium. Only after countless supernovae seeded iron, silicon, and carbon did worlds like Earth have ingredients to build from. Our orbit through this region brings encounters with gas clouds that can refresh local chemistry, but rarely enough to disturb stability. Each passage adds a touch of variety without breaking the rhythm. From a broader view, our system's long piece is a small interval in galactic time, yet even small intervals can cradle long stories. The dinosaurs rose and vanished. Mammals emerged. Human eyes learned to look up, all while the Sun moved less than 1% around its galactic path. Continents rearranged, species appeared, and the sky beyond remained mostly the same. That constancy anchors imagination. It reminds us that scale can soothe. What feels immense and unknowable from here has its own gentle order. The galactic habitable zone is not a fence, but a suggestion, a wide region where conditions lean toward calm. Planets certainly orbit in harsher quarters, near the core or in the outer rim. Some may harbor their own forms of endurance, but our middle distance offered chemistry a chance to persist. Oceans could linger, atmospheres could layer, time could stretch long enough for memory to evolve inside matter. The galaxy's pulse slowed just enough here to let life hear its own heartbeat. This place, this quiet, the lane of the Milky Way, asks nothing from us but awareness. It gives us the raw materials and the clock. The rest unfolds at whatever pace curiosity allows. When you look toward the sky and see the dim river of stars, remember that we're inside it, part of the pattern that balances chaos with stillness. The Earth's orbit, the sun's long loop around the center, the drift of the galaxy through larger space, all are motions within motions, perfectly slow. In that slowness lies comfort. The galaxy is busy, but not hurried. Energy and matter keep their appointments without haste. Our home floats in that steady rhythm, close enough to the main flow to share in its warmth, far enough to dream without interruption. Like a quiet neighborhood under distant lights, the Milky Way's gentle zone keeps its promise to hold a space where possibility can take its time, and where the night, for now, feels endless and kind. The galaxy doesn't hurry. It turns, it breathes, it balances transfers of mass and momentum the way a forest balances growth and decay. Bar patterns guide gas inward, spiral crests light, brief blue knots that fade to red. Black holes set the scales for orbits nearby, without demanding attention from those far away. Dark matter holds the rim, quiet and sufficient. Halo stars carry letters from an earlier tongue. Disks record the daily language of now. Feedback from deaths stirs the nursery for births. Streams tie former companions to our present, long after their cores dissolved. You don't need to remember every figure to rest inside these truths. Motion is continuous. Structures persist long enough to study, then evolve into others with reasons we can name. Tools refine, and what felt like a smear resolves into lanes. This is not spectacle. It is a dependable architecture where change has rules and outcomes have intervals wider than worry. Let your breath match that scale for a while. Slow in, slow out. The faint band above your childhood memories was a corridor through our home, seen from within. If your eyes close now, the map remains. Steady as a heartbeat too slow to hear without instruments. Stars will keep forming in cold rooms. Elements will keep returning to the mix. Streams will keep unwinding their histories across the halo. Somewhere a cluster will shed its last bindings, and its children will join the field.